welcome to everybody, and thanks to all that have joined us for this STARS tutorial. So that is based on the technology innovation analysis, and here we are on the first part of it. So there will be 3 more tutorials on the different other innovation trends. So I would like first to introduce briefly myself. So I'm Florence Masbernat, so head of the academic partnerships and Europe within RAILENIUM. And I will today introduce our agenda and the context of this tutorial. So just you can see the agenda. So this tutorial is about the sustainable and green rail system and green freight logistics chain. So I will manage the introduction, and here I must excuse our managing director, Bertrand Minary, that precisely had to join an important meeting about freight and innovation at the ministry, French ministry. So I will have the task to replace him today for this introduction. Then I would like to thank first of all very much our speakers that will, I think, provide very great insights for this webinar. And I know that maybe some of them could not attend until the end of the meeting. So we are very honored today to have you. And so the first topic will be from Mr. Josef Doppelbauer, that is Executive Director of ERA, the European Railway Agency. So it will be about how the regulation and innovation may accelerate the railway freight markets. And then we will have another presentation from Mr. Michael Haddad, that is Innovation and Partnership Director from ALSTOM, about the innovation solutions for green railway. And then from Mrs. Constance Banholzer, hope doing well with your name, from ÖBB, that will present the digitalized and automated rail freight operation tools. So after these 3 presentations, we will have a small session for questions, but you can also use the chat and the conversation to put the questions. And anyway, we will see how to manage them after the meeting if necessary. So I start first with the introduction now. And yes, so why first did we manage this technology innovation analysis? So it was RAILENIUM that developed this in the frame of STARS to aim to provide SMEs an overall pictures of railway major innovation trends and advanced technology paths. As you know, the STARS program is dedicated to boosting SMEs in the rail sectors with advanced technology. So this should contribute to enhance awareness of them and their capabilities to adopt advanced technology, and also perhaps to better identify the railway industry changes and innovation associated roadmap. So the STARS tutorial part 1 objective is to present and also to illustrate 2 of the 8 innovation trends that were identified, and precisely involving testimonies of major railway sectors actors that are here today. So it will aim to constitute a relevant information basis to provide the SMEs a deeper insight of sectors' innovation approach. So just to remind the methodology summary that we were using to develop this technology innovation analysis. So first we started from the state of the art of the major R&D industry and expert of the railway domain. So meaning that we have been, of course, taking into account the SRIA, so the Rail Strategic Research and Innovation Agenda, and also based on the ERAC roadmap, and the very important Europe's Rail program. So from that, we could identify the changes that are important and the innovation trends, and also detail more the list of the technologies. So at the end, we also try to identify some key variables that should impact on the development of those innovation challenges and solutions for SMEs. So we have retained 3 main criteria: level of maturity of technology versus the time to market, the key skills, and also the budget to engage. So from this, we have been built a matrix detailing these 8 innovation trends we found out and all the technology challenges associated. It concerns hardware as well and also software. So this matrix contains the details, but then if we go to the next slide, here you can see the 8 innovation trends we have found out, and today the objective is to detail more the 2 that are the IT4 and IT7, rail as a backbone of a green freight logistics chain, and a sustainable and green rail system. So I will try to introduce on the next slide those topics. So that will be much more concretely described then by the different speakers. But to say the first sustainable and green rail system, the main stakes is to minimize the overall energy and resource consumption, as well as the environmental impact of the railway systems as a whole. And it also will help to accomplish a more attractive and climate resilient mode of transport in the long term. And so this means to develop new products and new services that will be essentially based on the leading edge technologies. So you can see that we have, for instance, 5 parts to detail how to manage this. So we will have to deal with onboard energy storage, for instance, with interoperable energy devices, modular and with standardized interfaces. As an example, more powerful battery system module will be needed. But also we will have to generate new algorithms that that will be able to optimize all this use of energy. Then we have logistic energy management that will include all the railway system various components. It can be station, infrastructure, energy storage, or whatever. And there is a major topic there that is the smart grids that will be able to supply electricity to the railway systems. So there we know that it will be necessary to increase the availability and also energy efficiency, and that will be also needed there to use advanced information technology. So for instance, we will need to improve the renewable energy assets performances like photovoltaic, for instance, but also to design algorithm based on artificial intelligence, to be able to refine all this production, consumption of energy. And another important topic is energy harvesting systems to optimize the sensor autonomy. As far as you know that, for instance, to develop predictive maintenance, we need to be based on IoT sensors and networks. And for that, if we don't want to increase too much the power needed for those devices, we need to optimize and take appropriate energy that we can use. For instance, we can imagine antenna design that will use and collect electromagnetic energy to feed the sensors, so that will deliver an autonomy. And we also need to reduce, of course, these devices to be able to integrate them on the rolling stock, for instance. Then we have also a topic concerning the capacity of the vehicles to be attractive and accessible in terms of sustainable design. and services. So, for instance, it means to improve the comfort of the next train generations, focusing on new functions of materials and new generation of those materials. So, for instance, software to adapt lighting or acoustic levels depending on the people's concentration, can be also for air conditioning, or to have very new materials for interiors and exteriors to be able to respect the circular economy principles. So we can also highlight also the importance of the electromechanical components that could help to minimize consumptions, emissions, noise, and vibrations. So if we go to the next, then the second innovation trend develop and more or less link, it is about the green freight logistic chain as a backbone of the rail. So here, as far as you know, it's needed, of course, to increase a lot the part of the freight compared to the road today. And a shift is necessary, and for that, it will be necessary to drastically enhance the rail freight logistic chain performances and services. So we will need also to accelerate the train, all the system, wagon, infrastructure, maintenance, and operations, as well as to modernize the wagon fleet to support very high level of services. So here we can say some major stakes we identify about to, and that are very much based on digitalization, which will have a very high impact. So develop digital customer platforms that should offer new services to the customer, allowing real-time management of this logistics chain. You can see that that will be based on capacity planning with algorithms supporting decision-making tools, or also data from using data and sharing data. That's a big issue through centralized databases, or using conceptual data models supported by suppliers. And on the other side, another very important issue that will be very much developed here. So I will not say too much, but it is digitalized and automated rail freight operation tools, because we need also to have very seamless operation between all players in the rail freight sector. So especially, I think we have the topic of the digital automatic coupling in terms of development and deployment. And this will also open two very new fields of R&D, and like wireless communication technology we could implement on new couplers for shunting and other operations that are very key for the freight. And at the end, also, we need to have more multifunctional and modular wagon to modernize the fleet of the freight cars, and to be able to have, for instance, new lighter wagon frame for multiple uses, and that will be adapted to very specific needs for transportation, and interfacing also modular container, for instance, for a wagon, to be able, if possible, to have heavy loads, and also easy to unload. So this is more or less the end of my introduction, just to highlight how much, in fact, we need new devices on one side and very advanced technology on the other, like based on digital and automation of systems. And I would like now to go more in the testimonies of the different actors that will very much and better than me illustrate this field. So I'll let the floor to Mr. Josef Doppelbauer, if you I'm very pleased to give you the next part.
So many thanks, Florence, for the introduction. Good afternoon to everyone. I would like to start by recalling that the topic of today's tutorial is on innovation. And we need first to have a common understanding what we mean by innovation. And in the most generic form, innovation means to introduce a new product, service, or process that increases customer value. In the rest of my presentation, I will use a more narrow definition of innovation, meaning an innovation is something new and useful that responds to a stated problem. And as Florence has indicated, the stated problem is the challenge that we have with the climate change and the objectives in regard to the decarbonization of transport. There, one obvious solution is to shift transport volume from road to rail. On this slide, you see a number of advantages of rail in comparison to other modes of transport. So it's 5 times less CO2 emission, and in particular, it is 10 times less energy consumption by unit of transport, meaning that by shifting freight from road to rail, we would drastically increase the energy efficiency and hence also the decarbonization of freight. To illustrate the potential of a model shift, on this slide, I show the assumption that the road freight that goes over distances longer than 700 kilometers is shifted to rail. And the potential here is that by doing so, we would immediately arrive at the 36% modal share for rail. And this would also allow us to save 40 million tons CO2 per year, which corresponds to 21% of the emissions of transport, so which is already quite significant. In reality, the distance should be 300 kilometers because this is the distance that one driver can do in one day and going back home. So this is the potential, but unfortunately, the reality, and I show the situation on the next slide, the reality of the modal shift from road to rail is not so positive. There has been a target for the rail freight modal shift, and I'm speaking of the European Union. Since at least 2010, a target has been stated of 30%. The modal share of rail in reality is around 18, 19%, and if we look more closely, it is even going down. So the latest figure, and the figures are from Eurostat, is slightly below 17%. You know that the sustainable and smart mobility strategy of the Commission has the objective of doubling the rail volume by 2030. But what you can also see that the further we progress on the timeline, the more difficult it will become to achieve the 30% target. And usually in such presentation, then the statement comes, and now a miracle occurs. But we need more than a miracle. We need concrete actions. There is some actions going on. Europe's Rail joint undertaking has been launched, but the results of Europe's Rail, according to the statement of their executive director, will hit the market in 2031. And also we will hear later by Constanze that DAC will hit the market after 2030. So this is indeed a call for action. If we look into the individual countries, then we see there are some interesting differences. Germany is by far the most important market in Europe for rail freight, covering about 30% of the volume, but Germany reflects the same behavior as Europe as a whole, going down. Czech Republic and Austria they have lower volumes but higher modal share, but also going down. France and Italy, they have been able to increase the modal share in the early 2010 decade, but also in the last 5 years, it went down. If we compare these figures with the situation, for instance, in North America, United States of America, there the modal share of rail is around 40%. And we also need to state that the productivity of rail freight is, of course, much higher in North America, because there you have axle load, which is 32.4 tons in comparison to 22.5 in Europe, and train lengths of more than 4 kilometers. And in Europe, we struggle to achieve 740 kilometers. Then we have massive issues with the quality and the punctuality of freight trains in Europe. I have quoted from the latest report, for instance, on the Rhine-Alpine corridor, which goes from Rotterdam to Genoa, which is the most important freight corridor in Europe. The average train delay for trains crossing a border is around 100 minutes per train. On the rail freight corridor 7, the average delay is more than 250 minutes per train, so more than 4 hours. Again, back on the corridor 1, the Rhine-Alpine corridor, there we can also see that 60% almost of the trains are within 30 minutes delay, meaning that the other trains, more than 30 minutes, are then really, really strongly delayed, meaning 1 day or 2 days delayed. That leads us to the overall situation of international freight trains. And there are 3 very difficult factors for the freight trains. Freight trains in Europe in general, but cross-border freight trains in particular. The first issue is that freight trains share the network with long-distance and regional passenger trains. So we have mixed use of lines. Priorities need to be managed, but freight usually gets the leftovers. Second, we have cross-border issues, and I will come back to these in the next slide. The agency has performed a study which we have published in December last year, meaning that we can have waiting times of up to 6 hours at an international border, which of course is not very useful if rail should compete with road. And thirdly, we have the capacity and the quality of the network, which is determined by the infrastructure manager. Now, theoretically, rail freight should be more economic than road because of the scale factor. You have 1 local driver for 50 wagons, and the longer the distance is, the smaller the overhead of shunting and train building becomes. However, in reality, for most cases, before you can actually economize the advantages of rail, you hit a border, and every border adds additional cost and additional time. And there is several factors, starting from the different languages, from national rules, timetable mismatch, and so on and so forth. So in order for rail to be competitive in the freight market, the cross-border issue is the critical aspect, and it needs to be solved. With this, we come, of course, to the contribution of the agency. And the first aspect that we need is, of course, European thinking as the basis for improving the situation, to allow frictionless train movement in what we call a single European railway area. We have already made some progress. we have established the possibility to have go everywhere operators and rail vehicles, single safety certification, and EU-wide vehicle authorization by the agency with the Force Railway package. Then we harmonize operation at European level with the revision of the TSI operations, and with the latest TSI package 22, we have increased interoperability, and we have introduced the ERTMS game changers. Now, this revision package, and it has been positively voted in the risk of the 30th of March this year. We see a number of important aspects that support rail freight. In particular, we have introduced support for intermodal transport. In general, regulation is needed for promoting innovation because we have different actors which need to be synchronized. Take the example of ERTMS. It's absolutely useless for an operator to install ERTMS on his locomotives if the infrastructure is not fitted with ERTMS. So this needs to be synchronized. The fragmentation in national markets, of course, is a major blocking point for innovation, because you have n times the cost, because you need to develop different products for each country, and then you have only one end of the market. So actually, the efficiency of innovation is scaling with the square of the number of different countries and different regulations. So what can we do in order to improve the green freight by rail? And the question is where to innovate. First, I need to state that we have, of course, the situation with the transport demand. And transport demand is also changing by category. With, for instance, the elimination of coal for heating and as industrial-based product, there will be less coal to be transported. But then we have the problem of choice. So freight forwarders have to choose between the various transport modes. Then there are some criteria for this choice. The rail affinity of the good, meaning dry bulk goods are very good suited for rail, but logistic packets are less so. Then the accessibility, then the cost and the quality. And cost of rail freight is one area where we have the call for innovation. Some of the aspects were already mentioned in the introduction. Cost means the capital expenditure, means the operational expenditure for maintenance, and means also the people. So digitalization and automation can significantly contribute to improving the cost. But another key issue is, of course, the quality, meaning the transport time, the punctuality, and the real-time information about the transport time. In the end, if the forwarder has made the choice for rail, we need to provide the train capacity. And I will come back to the question of capacity later, because this is a key issue that can be the real bottleneck. So one of the aspects is we need to eliminate bottlenecks in critical nodes. And then we also need to take into account unforeseen events and disturbances. And I have in small print the figures from Germany last year. There had been in 2022 17,000 signal failures, 38,000 switch failures, and 33,000 level crossing failures. So on average, 230 disturbances per day. And here, technology, preventive maintenance, digital supervision can contribute a lot. So in the end, the greening freight means to improve the modal share of rail against the modal share of road. This is the Green Deal objective that I have noted here. A substantial part of the 75% of inland freight should be shifted to rail and inland waterways. But there is another factor that plays against rail, because goods become lighter. We transport less coal and we transport more parcels. So in order to compensate this, we would possibly need longer and heavier trains, but this needs to be supported by the infrastructure as well. And now we come to the fundamental role of the infrastructure design. I show two examples of the screen. To the left, you have a 20-kilometer segment with the opposite direction not signaled and with no possibility to cross over. This is more or less the situation that we have in Germany today. On the right, I show the situation like it exists in Switzerland or Austria, where we have regular crossovers, so at least every 4 to 5 kilometers, and where the second direction is also fully signaled. In terms of travel time, there is, of course, no difference, but the capacity on the right side is already 4 times higher. Some might ask whether there is different situations. Well, if we go to East Europe, we would see situations where the speed itself is limited to below 40 kilometers because of the bad situation of the infrastructure. Or in France, trains cannot operate during the night because the railway lines are closed. The real and fundamental issue is if we have an obstacle on the railway line. This obstacle could be a damaged vehicle. This obstacle could be an animal that is killed. So in the left situation, the travel time would increase to 30 minutes and the capacity would be reduced to 1.5 trains per hour. The right situation, travel time would still be approximately the same, and the capacity goes down to 12 trains per hour. Now, I hear digital will solve all of this, but if we look very closely to the lower picture on the left side, yes, digitalization can increase the travel time, but the capacity will still remain at 3 trains per hour. So it's still a factor of 4 lower than in the case where you have an adequate design of the infrastructure. So either you need enormous contingencies in your planning to be resilient, or an upgrade of the network to introduce bi-directional signaling and to introduce the crossover points in regular distances. Of course, a resilient network will also be more positive for accommodating construction work. Now, in innovation, it is always important to identify where is the bottleneck. And I am showing here an example that is related to the presentation that we will hear later on DAC. The digital automatic coupling, of course, dramatically improves the shunting and the coupling of trains, which is in the middle. But you have to consider, on the one hand, the arrival rate of wagons, and if the arrival is very slow, then the speeding up of shunting doesn't help a lot. On the other hand, you have the capacity of the line to accommodate train. So if the line can only accommodate, say, 2 freight trains per hour, it is not very useful to speed up the shunting operation very much, because then you just increase the waiting time. So the message is the innovation activities need to address the bottleneck, and there always needs to be a balance. Of course, DAC will also allow to have longer trains, and longer trains will improve the capacity. But we have to be very careful when we speak about business innovations. In one large European country, an innovation was introduced called network trains, where the idea was you have block trains and the spare places in that block train are filled by single wagon load. But what is the consequence? The consequence is you slow down the block trains because you run them over a shunting yard, and you also slow down the normal single wagon load because they have now to wait longer before a train is completed. So with that, I come to the end of my presentation, to the conclusion. The real situation with modal shift to rail, unfortunately, is not good. We need to come from good intentions and wishful thinking to concrete actions. The target is clear. We need to shift transport volume from road to rail. The strategy, of course, needs to address the obstacles and challenges. These obstacles are predominantly the fragmentation of the European railway system. Secondly, we need a coherent and maintained and resilient infrastructure. The third aspect, and I believe that is also something that should foster innovation, is a market-oriented approach focusing on reliable combined transport over longer distances. So we need a Europeanization from national patchwork to a European network. We need institutionalized European traffic planning and capacity management. We need digitalization in an intelligent European railway network. And last but not least, we need multimodal integration. So with these ingredients, we should find the right targets for applying the innovation possibilities, the innovation trends that we have heard in the introduction. And with these measures, we should improve and progress towards the decarbonization of the European freight market. Thank you very much.
Thank you very much, Josep Doppelbauer, for this presentation. I think it's very interesting and very demonstrating that at the end, innovation is, yes, there are some components, but you need to address at the same time the different issue and the bottlenecks, as you say, and to remove the obstacles. And you can see that there is some urgency, as I understand that you show that we need to double this share part by in 10 or 20 years, and it will be more and more critical. But we have some innovation programs. I don't know if they are enough, but yes, I think we think that we have very great questions. I don't know if there are questions from the participants they would like to ask. They will have to ask now.
Yeah, I have collected one question from the chat, which is on the slide, the third one.
Mm-hmm.
And other questions are own questions. If you can see the questions, you could immediately answer to that.
Well, I see the questions on the screen, and of course, transporting fruit over long distances is a very good example because, and I live in France, and also here we get a lot of agricultural products from Spain. There is, of course, the drastic interoperability issue between Spain and France because of the different track width. But one response to that is, and I have mentioned this in my presentation, is the intermodal transport. So you can load containers, but you can also load semi-trailers on trains. And with that, the different rail net is not the critical obstacle. But still, we have, as I had shown, the problem whenever we cross a border, we have different language, we have different operational procedures. The locomotive needs to be changed, the driver needs to be changed, and a lorry can run from Romania to Portugal without any technical or operational hurdles. So this is a very critical point for rail.
Would you say something about the other two questions?
Well, on the SMEs, this is a valid point because, you know, the process of building, for instance, the TSIs involves the consultation with the sector. We are the so-called representative bodies, but the representative bodies are, of course, representing the sector in general. And therefore, there is a strong weight for the large enterprises. I know that, for instance, in the railway industry, they have a specific representation of SMEs in their presiding boards and try to represent the SME as well. The second point, which is also in the question, is how can they be informed? And there I can only say we as an agency, we do our utmost to have all the information easily accessible with our website. So I can only encourage the SMEs, go to our website, look for information. If you don't find the information that you need, there is the button, contact us, and this will generate an email and then we will reply to you. On the adoption of innovation in the railway system, for example, hydrogen, I believe this is possible by what we have already foreseen now, that there is always the possibility to apply innovative solutions. So there can always be made exceptions for technologies that are not yet regulated. And there we have again two aspects. The first aspect is to make the operational trials possible, for instance, for hydrogen train, but I understand that in Germany, such trains are already in commercial service. And the other aspect is, of course, to allow the regular service of such new technologies. So for me, the critical points are to manage the safety risks in all of this, so to make sure that we don't kill any new technologies because of being afraid that we cannot manage the safety risks.
Thank you very much. I think it's very clear. Lutz, if there are not any other questions?
No further questions in the chat.
Okay.
Last chance to raise a question directly. By raising your hand or seems not to be the case.
Okay. Thank you very much. Thank you really, Mr. Doppelbauer, for your intervention. I know that maybe you must leave our meeting, but thank you again.
I will stay on.
Okay,
I have still some time, so thank you.
Great, thank you very much. So we move to ALSTOM. I think the next presentation, if Michael Haddad is confirmed, is here.
Yes, I am.
Okay. Hello.
Hello.
Bonjour, Michael.
Bonjour. It's not going to be easy to speak after Joseph. He has said almost everything because everything he has said is true also for passengers. But as I was listening to him, I just added few slides to my presentation in order to get into some details and explain how we can innovate for green railways. So I am sharing my screen. Up. So as the title of my presentation, can you see my screen?
Yeah, but it's not the presentation mode, it's the working mode.
Yeah, up. Sorry, here it is.
Yeah, better.
So as the title of my presentation is about innovation solutions for the green railway and not for green transport, I will focus on technologies for rails, but I wanted to share with you the context and why we are doing what we are doing. And I think I am 100% aligned with what Joseph has said, so I will add some information. So first, I guess you know that CO2 emissions are mainly due to the I mean, you can divide it, in fact, the contribution to greenhouse gas emission into 4 different sectors, each of them representing about 25% of the total. So transport is responsible for 25% of emission. Of course, depending on the country where you are, it could vary a little bit. In France, for instance, it's 30%, as we have nuclear power plants. Electricity is less carbon heavy than in other countries, but it's the numbers you have to keep in mind. And when you are looking at the, maybe I could use a pointer, yeah. When you are looking now at which modes are contributing to this greenhouse gas emission, in fact, you can barely notice the contribution of rail, and it's mainly road that is responsible for that. So the easy answer to the decarbonization of transport should be to promote a modal shift from road to rail and from air to rail. And as Joseph has said, this is what we should do, but it's not in the plan, and it's not at least what's going to happen in the near to mid-term. And this will impact, in fact, the way we innovate, of course. So why is it like that? This is the few slides that I've just added listening to Joseph. And sorry, the graphs are in French just because the data are from France. I have the same for Europe, and we have some insight also from the OECD International Transport Forum, and all the numbers, all the are going the same way in Europe and worldwide. If you look at the past, and I know it's a bit complicated, but in gray you see the emission, the CO2 emission from the transport sector in France. And if you are looking at where it's coming from, I will explain the Kaya equation. It's mainly driven by the increase of the transport demand. Because worldwide the population is increasing, we have an economic growth. So the more the population is increasing and the more you have an economic growth, the more people want to move. And not only people, but also goods. So on the top it's passengers, and here it's freight. And in order to compensate, in fact, the CO2 emission, you could use modal shift, energy efficiency, carbon intensity of energy, or vehicle occupancy efficiency. And in fact, none of them really compensate for the increase in the passenger demand. And regarding modal shift, it even went into the opposite direction. We are using more and more, at least in France, transport modes that are heavy on carbon. And why is that? In fact, if you look at the past, starting in the 70s, in fact, people are mainly traveling by road. It's 80% of the passenger kilometers. And rail has been for 50 years at 10%. And aviation is increasing. And if you look at the data from the International Transport Forum Outlook for 2050, they are exactly forecasting that for the world. Aviation will see the demand multiplied by 3, while rail will only see a growth of 50% in terms of modal share, and road will decrease a little bit. So in fact, even though we are talking a lot in the railway sector about modal shift, it has never happened, and no one has planned that it will happen sooner or later. So we have to live with that. And again, if we deep dive in the mobility in France, so you see on the graph from the 19th century, so 1800 to now, you can see that during 150 years, people were mainly using active mobility. So they were walking and horse. And then the car came. And starting in the 70s, we started to remove tramways, for instance, in the city. And it was really the kingdom of the private car and private mobility using cars. So in the United States, but again in France, people are traveling 40 kilometers a day. And why is that? It's just because the city, their life is organized this way. So coming back to a world where there is no car or no private car is almost impossible, or at least it will require a complete change in the way the society is organized. And even though in France you have the numbers, so again, sorry, it's in French, but the line you have to read is this one. Ici mean public transport in French, and here it's railway. So this is the passenger demand in terms of passenger kilometers, and this is the modal share of rail in France as forecasted by the French government. And I guess you know, at least if you are French, that SNCF, so our national railway operator, has a target of doubling its modal share by 2030. But now, if you look at the plan of the French government, they only see a 20% increase. So it means that the strategy of our country is not aligned with the strategy of the national operator, meaning that they don't have forecasted any budget to sustain or to help the railway industry to improve or to increase the capacity to invest in infrastructure. It's not in the plan. And again, so if it's not in the plan of politics, then maybe we could leverage a change in the consumer behavior. And we have some studies trying to understand how people are choosing the way they travel. So there is a very good one from McKinsey that I show here. There is another one from Credit Suisse, and they all show that the way people will choose their modes of transport is first based on the price, then on safety, then convenience, reliability, speed, comfort, independence, availability, easy booking process. And in the 9th or 10th position, you find sustainability and ecological footprint. And I know it's not, and this is a very recent study from 2022, and it was focused on people under 40. So we're not talking about the young generation planning to stop using planes. Not at all. They intend to take the cheapest and the fastest way of travel. And it's different if you were living in China and even India in the Credit Suisse study. Countries where people are already experiencing global warming and consequences of diesel pollution are more ready to shift than people living in Europe. So this is something we have to keep in mind also, that the only way to decarbonize transport is to somehow provide the consumers or the travelers what they are looking for, meaning a cheap way of transport, safe and convenient. And I was 2 weeks ago at the Sustainable Logistics Summit organized by DHL. And to come back to what Joseph was saying, DHL has absolutely no plan to move its freight from road and air to rail. Rail was not mentioned during the 2 days of the summit about sustainable logistics. And again, why is that? Is that we tend to forget that by 2035, almost all the transport mode will be green. They all have roadmaps in order to be green. So green is not enough in terms of competitive edge in order to attract a consumer and passengers to rail. So knowing that, maybe I remind you the way we should or we could decarbonize the transport sector. I don't know if you are all familiar with the avoid, shift, improve model or the Kaya equation, but in order to decrease carbon emission, you can play with transport demand. If you reduce the transport demand, then you emit less greenhouse gas. But this is very difficult. As I said, it would have a colossal social impact, and only politics can do that. It's not up to the industry to do that. Then you could operate a model shift, moving from a heavy carbonized transport mode to a low carbon mode. But as I said, it has never happened in the past, and doing that will be again very difficult, especially if we are not fulfilling the passengers' requirements. Then you can play with the energy carbon intensity, so moving from diesel to hydrogen or from diesel to electricity, and I will come back to that. You can play then, you can improve then the vehicle efficiency, energy efficiency. So the less energy you are using to move people and goods, the more you are saving CO2 emission. And then vehicle occupancy. So trying to put as many people in one train, for instance, or as many containers as you can in a train. And this again is related to passenger experience and services you can provide on board. So we see that, in fact, if we assume that we cannot, as being in the industry, if we cannot play with the transport demand, if we do not expect any investment from governments in new infrastructure and new way or new incentive to reduce the cost and stimulate modal shift, then the only ways we can impact the carbon emission of transport and railways is to use technology to decarbonize the energy we are using, and technology to improve the energy efficiency of our infrastructure and rolling stock. So now, if we're talking about energy, another thing we have to keep in mind is that the International Energy Agency has published a net zero scenario where they are trying to allocate green energy to all the transport mode, because green energy will be a very scarce resource. And the only way to achieve, in fact, being net zero by 2050 is to have this kind of allocation, which is very easy, in fact, to understand. The first rule is to say that any transport mode that can be electrified should be electrified, meaning that road and rail should have as a target to be fully electric by 2050. So that's why the European Union, for instance, is pushing to the ban of the internal combustion engine, or at least to remove it from road vehicle. And for rail, the trajectory should be to go full electric, but then it requires a huge investment in terms of infrastructures. And you see that in terms of energy, the way the International Energy Agency is looking at the future is to say, okay, we will have 95% of electrified line, some hydrogen, 2 to 3%, and still some diesel, because you have some mission profiles, such as the locomotive in the US, that you cannot, in fact, electrify, or it will never make it in terms of business model. And then you have ammonia or synthetic fuels and biofuels for maritime and aviation. So I know that some players are pushing for biofuels and electrofuels in the railway industry, but according at least to the International Energy Agency, it will never happen. We won't have a single drop of this kind of fuels in the future, just because it's a very scarce resource, and it will be dedicated to aviation, which has no other solutions. Then when we talking about green train or zero, we are most of the time forgetting about local emission or local pollution. So air quality should also be a key topic. So we should not only think about CO2, but also particles, NOx, and so on. So we should target a zero emission train or vehicle. And I think this one is a bit complicated, but also I was talking about energy efficiency. So when selecting a technology, and here I put the energy efficiency of burning an e-fuel and compared to the energy efficiency of being of running a train on an electrified line, you go from 15 to 16% energy efficiency from the plug to the wheel to 80% efficiency. So keep in mind that, again, if it's all about saving energy, you have to electrify. So now if we jump to the solutions, at least from ALSTOM point of view, we have a list, in fact, of different options. We think that some of them are aligned with the European Union taxonomy and are good for the planet, and others are not. So as you know, a train can operate with one energy or two different energies. So we have monomode, bimode, and hybrid solution. So if we look at the monomode solution, of course, we should get away from any diesel engine, diesel electric trains. And if it has to be monomode, then it should be an electric train under catenary. Now, in some cases, you can't electrify, so or if you can partially electrify it for cost reasons. So this is why we also have B-mode and hybrid solution. One is to use fuel cell multiple units. So it could be, I mean, it's never full hydrogen. Anytime you have hydrogen, you also have a battery. Then you could go also for a battery electric multiple unit. So it's a train with both catenary and batteries. You could go also for a diesel catenary train, so the DEMU, so a train that is most of the time running under catenary, and when it's not electrified as a diesel engine. Of course, it's not the preferred option, but in some cases it can be, it's better than full diesel. And we should get away also from diesel battery multiple unit. They are very similar to the hybrid car that will be forbidden by the European Union. So this is why it's not an option for ALSTOM. So we have different options. So how do we select which one is good for which kind of application or mission profile? There is a simple chart to have in mind. Most of the time people are opposing electrification, battery and hydrogen. In fact, we must understand that it's just different solution for different mission profile. If we are on lines where you have a lot of traffic and you need a lot of autonomy, then we should go for track electrification. Now, if it's a low density line and you do not plan to have more than 100 kilometers without electrification, then you should go for a battery train. So it could be a full battery train, or it could be a battery catenary train. And if you need more than 100 kilometers of autonomy, then it should be an hydrogen train. So meaning that or B-mode hydrogen and catenary train, the way we plan to have, for instance, in France. So I will just focus on the hydrogen train, as it was mentioned before my talk, but it would be quite similar to have a battery train. You replace, in fact, the fuel cell by batteries. And as I said, there are batteries in an hydrogen train. So the hydrogen train that we have today in Germany, the Eilint, which is in commercial services, it's operating now in a commercial line with real passengers. In this train, it was an Eilint, a diesel Eilint that we retractioned. We removed, in fact, the engine and the tanks and replaced them by hydrogen fuel tanks, fuel cells, and lithium-ion batteries. So this train has an autonomy of more than 1,000 kilometers and is in commercial service in Germany. So I have nice pictures of the train. You can use it if you are living close to Frankfurt. And this is my last slide about also what does it looks like, the infrastructure in order to refill this hydrogen train. You see here the refueling station we have in Bremerworde that was designed by Linde. And you can see how, in fact, the train will refill its tank. It's almost autonomous. The driver just has to get down and plug the pump to the train, and in some tens of minutes, it will refill the train. And this is it for my presentation. I don't know if you have any questions.
Thank you very much, first of all, Miguel, for this very complete presentation, and I think very
and maybe about
realistically the market and the reality. And we come back to this.
I didn't provide any information about how could SMEs be involved or collaborate with ALSTOM. I think first we are an industry and we are delivering product in the physical world. So I know there are plenty of stuff regarding digital algorithm, AI, and so on. Frankly speaking, we got so much request or solution from pure digital players that we don't even know how to sort them, and we have also in-house a lot of knowledge about all these pure digital stuff. What I think would be very interesting is to see, and I'm discussing quite a lot with colleagues from the aviation, maritime, and automotive sectors, is to maybe bring some solution, and I'm speaking hardware solution, that are already used in this industry and that could be very helpful for the railway industry. So small companies having products and willing to homologate them in the railway industry or discuss with us would be very welcome. Or any, again, technologies that are targeting energy storage or all components that we could use would be very useful.
Okay, so your orientation is more on hardware.
Yes,
than
because
software, because you say there are a lot of offers and this is complicated to, or it should be linked maybe to the hardware.
Almost every day I received a proposal about a new AI algorithm. The only thing that I should provide is money and data, but I mean, I have no way to sort or to say, okay, you are better than this one. And again, we have a full service of engineers working on AI, so we have our own team.
Interesting. Do you want to? There is, I think, some other question. Do you want to answer them? Yeah, or like major obstacles for implementation of the new advanced technologies?
Sorry, I don't have the question.
Can you see the question?
No, I can see that there was one on the deck, but I think it was not for me, no?
No, it's for Mr. De Palbo. You're right.
Yes.
But there is one question that is, I can read it to you because I see it. It's what are the major obstacles for the implementation of the new advanced technologies in decarbonizations? Yeah,
so there are many. First, maybe it's good news, but the backlog of ALSTOM, and this is true for many big companies. The backlog of ALSTOM is now almost 90 billions of euro for a turnover of 15. So we have 5 years of turnover to execute. So a very disruptive, innovative, solutions. It's not very easy internally, being the innovation director, to push them because we don't have enough resources in order to both deliver and also work or allocate experts on some topics. So this is an issue, and it takes time to integrate them. And most of the time, we are a low volume market, and we have a huge regulation norms and so on. So for our industrial partners or suppliers, they should invest a lot to design a product or a component that will be specific for railways and that will sell at very low volumes. So then it's very expensive. And this is a problem. And the other one is that as long as we don't have a price for the carbon that is relevant in terms of market, then all the solution, or as long as there is a big change with the Ukrainian war, unfortunately, now that energy starts to be very expensive. But if there is no incentive, and I'm talking about money, in order to save energy, then all the new solutions most of the time are more expensive. And as I said, price is key. So if you increase the price, then the model shift is going the opposite way. So price is key.
Right. I think the question is also, the next question for Mr. De Palbo is linked to DAC. So should we perhaps put it after the Constance's presentation, or what?
I think Constance will answer this question in her presentation, so I don't have to answer.
Okay.
So I see one on particulate. Maybe I skip this one. I can answer this one if you want.
Okay. Yeah.
So what about particulate matter for green transport? As I said, we are targeting, because we're talking green, and most of the time we assume that green means low greenhouse gas emission. And no, I insist, it should be no emission, meaning no particles, but no noise and no vibration. It's not only about low CO2 emission. So particles, that's why we don't want, as ALSTOM, to invest in biofuels and electrofuels or synthetic fuels, because when you burn a hydrocarbon, even though you can be almost carbon neutral, in the end you produce particles and NOx and so on. So that's why we want to get rid of that. And once you've said that, you may have solved one problem, which is a combustion particle, but then you have other particles, such as brake particles. So we have ongoing research project, and this is especially an issue for metro, where you are in a confined environment and air quality can be very bad because of brakes. So of course, anything related to electric brakes or new pads or new systems in order to reduce this emission of particles is key, and we have ongoing research project, more at the academic level, but it's a work in progress.
So I haven't seen any other question to Michael. Okay.
No, I didn't see.
Okay. Maybe you can. I see the time also going on, so maybe thank you very much again, Michael, for your presentation. Very, very
You're
interesting
welcome.
also. And I think now we can leave the floor to Mrs. Constance Banholzer.
And I will disconnect, but you can reach out to me if you need more information, because I need to have lunch. Sorry.
Okay.
Bye-bye.
See you. Bye.
So wonderful. Thank you very much for the invitation. I think the audio is working.
Yeah, it's working, I think.
I'm quite happy to be here today at the STARS tutorial, and I will be talking about digitalized and automated rail freight. And one of the parts that I will be talking about is the digital automatic coupler. So we tried to cover the question that was written down in the chat during the course of the presentation. And I would like to give you a short overview why we are working on this, why we believe that it is the game changer for Europe's rail freight sector, or one game changer, I would call it. I will be talking about the framework, so meaning the projects, the initiatives, mainly under the umbrella of Europe's Rail Joint Undertaking. So Europe's Rail Joint Undertaking was already mentioned before. Just shortly about the implementation. And last but not least, I would also like to talk about the role of SMEs under the example of one project and what we have learned so far. To me, my person, I'm working for the Austrian Railways. I'm an ÖBB DAC program manager. I'm also responsible for the project management of one cluster of the European projects I will be talking about. And I'm also supporting a European initiative, which is called the European DAC Delivery Program, and it is enabled by Europe's Rail Joint Undertaking. If I go to the next slide, I try to make the introduction quite short because I think also the time is not enough to extend it here like extensively. You have been hearing about the digital automatic coupler. Just quickly what it is about. Let's just depict that for more than 100 years we have been coupling using the screw coupling system, and it includes actually heavy manual work. So a person, the shunting staff, the people that are working on marshalling yards need to lift more than 20 kilos. They need to walk up and down the train. And obviously also in this environment, it's quite hazardous because the wagons are moving, and hopefully you will also agree with me that this is a process activities that has definitely room for improvement in terms of efficiency. In the presentation before, also by Mr. Doppelbauer, it was mentioned that the rail freight sector has to deal with several challenges. One of them is like the limited network capacity. I would like to add that in rail freight, we are very much dominated by manual interventions, and also partly we do not offer the customers the services they wish. And our vision actually is to couple approximately 450,000 wagons automatically, including power and data lines, in the next decade. And here, actually, when we are talking about the power connection, it's a 400 voltage system currently that is being developed in the project that I will be talking about later on. And on the one hand side, we're talking about the digital automatic coupler, but we also need to be certain about that it's not just about the DAC itself, it's not the standalone technology, but it's actually the enabler for full digital freight train operations. And the DAC will directly or as an enabler allow us to generate benefits on a European level. And here are some benefits that I would like to talk about. The one hand side, on the left side, you can see that it allows us to, in a smart way, increase the capacity. So we could prevent building like huge amounts of new infrastructure. It allows us to increase the productivity. So mean in our operations, we are faster and more efficient, increasing our quality towards our customers. So the customer orientation is of utmost importance in the rail freight sector. And this would all lead to an increase of competitiveness and growth, possibly also to enter new markets. And what we should also not forget, because it's sometimes, I think it's forgotten, I have the feeling I would highlight it very much, it's also increasing the worker safety because they are dealing with this on a daily basis. And definitely also the value creation. And I would also like to draw your attention to the right-hand side. Is we heard it before that shifting volumes from road to rail is of utmost importance. But if we manage to do so, we will be also able to contribute to the European Green Deal objectives. I was pointing out before that the digital automatic coupler is not a standalone technology. And here I just wanted to give you a crisp overview on the enabler function for the full digital freight train operation. So with the connection via the power and data lines along the train, it will be possible to implement even more applications on the freight train. Just to pick some of them, with the digital automatic coupler, the automated coupling and uncoupling comes along. But with the power and data line, also very time-consuming processes during train preparation can be automated and digitalized, for example, the automated brake test. Mr. Doppelbauer also explained we need to reflect very much on where the bottlenecks in freight transportation are. So now you have been hearing from my side, yes, in shunting operation, we will be more efficient. In train preparation, we will be more efficient. This is all correct. But if you just come to the point where you increase, like you are prepared earlier, but the waiting times increase, this also doesn't help. So obviously from network side and for the train run process, there are also improvements are possible. And here also one role plays the DAC, definitely not a single role. When we are talking about the ETCS level 3 deployment for the moving block operation, also the train integrity must be assured at each point in time, which could be possible with the digital automatic coupler. And those are just some functions, benefits that I wanted to highlight to you. And we as a sector would then be able to reap those benefits according to processes where we automate or digitalize in the shunting, in the train preparation, train run, and etc. This sounds definitely as a major transformation project. It definitely is. And in the next decade, approximately 450,000 wagons shall couple automatically. I mentioned this before. And I would like to point out, because I think it's also important for the role of the SMEs, to know in which framework, in which initiatives, in which projects we are actually working. One initiative that I would like to point out, it's depicted in the middle of the slide. It's abbreviated with EDDP, so the European DAC Delivery Program. And it's an open platform for cooperation and collaboration of various stakeholders. So partners that are contributing and working there, it's the railway undertakings, the infrastructure managers, the wagon keepers, rail supply industry, but also other key stakeholders, academia and SME. So it's open and everybody can join and contribute there. What is the purpose actually there? The main focus of the work driven in the European DAC Delivery Program, especially looking at the future, is working on the migration. So how will we be able to deploy the digital to automatic coupler and further DAC application and train functions? What is important for this to be worked out? It's definitely having a clear understanding, a solid basis on the fleet, how we are going to retrofit, how we are going to migrate, how we will be able to assure the appropriate and needed funding and financing, and the infrastructural or IT adaptations. So this is the European DAC delivery program and what the focus of the work is. Obviously, when we are talking about a transformation, a change in the rail freight system, important key players such as the European Commission and the ERA are obviously also involved, because this is strongly connected, for example, to standardization and the TSI processes, and not to be forgotten, also the European Standardization Organization. Additionally, and what is here being complemented is, so the one thing is how we are going to migrate, but the what we are going to migrate. And here we still have some meters, I would say, to go. And this is being dealt within a project under the scope of, or under the umbrella of Europe's Rail Joint Undertaking, the abbreviation you can see here, the FP5, the Flagship Project 5. And the main focus here is to work on the technology, test it, demonstrate it, and bring it to a market readiness that could be then afterwards deployed. This is the overview I wanted to give you, and which scope and framework we are working. Now I would like to get much more to the Europe's Rail Joint Undertaking Flagship Project 5. We are actually running out of time, but I hope all those messages were not for me, because I haven't read the chat so far. Then please mention it to me. Here I just wanted to point out that each activity in like the scope of the Europe's Rail is being then also from the right hand side, the innovation pillar, also aligned with the system pillar. So the Europe's Rail is organized in two pillars. And with the iteration from like the innovations that are driven by the industry, by the operators, etc., and the projects and the results they are developing, there is the system pillar who is taking care that in the end we are also meeting the objectives that are defined in the Single European Rail Area scope. So this is very important also to understand that there is a dependency and also an ongoing iteration, so that we do not lose track or in the end up with fragmented solutions and project outcomes. Now I will be running a little bit quicker. I think this will be helpful. I wanted to come to the Flagship Project 5, which we are working in also from ÖBB side. This is a project where actually 71 partners are working from the whole rail sector, end users, large industry, railway undertakings. And I also wanted to point out for you that we have startups and SMEs also included in the project. Our approach, we are working actually in two clusters. So one on the seamless rail freight part, and this is then being complemented by the, this is then being complemented also with the full digital freight train operation activities, such as, for example, okay, someone has taken control over the presentation. Could you go to the next slide, please? Yes. The project will be working and started last year and will last until 2026. And if we really, in a simple way, try to depict it, what we have done so far and what we are currently doing in this year is working on the operational procedures so that we are aligned and have a clear target, system architecture, authorization, risk assessment, and the technical specification. This is obviously building the basis for the technology improvement. And with this, the industry partners are able to develop prototypes. This will be tested in labs. And with this, we will be also able to run demonstrator trains, which will be then extended in 2024 and 2025 and until the beginning of 2026 to excessive testing. If we go to the next slide. Yes. Now I think I've informed you, like given you, like please go to the slide before, a brief overview on the digital automatic coupler and the why we see it as a game changer for the Europe's rail freight sector. Also the framework, meaning the projects and the initiatives we are working, mainly in this case under the umbrella of Europe's Rail Joint Undertaking. And now I would like to come more to the potential and role of SMEs from what I've learned so far. From our understanding in the research and development in railway, and I think it's also was mentioned in the presentation before, that the railway operating community needs to define the challenges. And I think the presentation from ALSTOM, it was also pointed out that we need to be clear where are the issues and for what do we actually need solutions. And as a complementary activity, industry, including SMEs or academia, should develop solutions. So this is how we could move forward aligned and in a harmonized way. A definite advantage for being involvement as an SME on those research and development activities is to getting quite early involved in shaping the future of the market developments. What we also see here is that the research and development, research and innovation activities, they really strive for developing outputs that are ready for being deployed on the later stage. It's definitely also worthwhile to work with big players, big companies, because they also have experience and considerable resources. It's also quite interesting to work in a large-scale European environment in those activities. And obviously, with the contribution in those projects, we should never forget the socio-economic impact on a European level, job market, new opportunities and growth. What obviously also is a challenge that I wanted to point out is that the institutional framework needs to be understood quite well. I wouldn't say that it's easy. It's also quite challenging. It's definitely also important to reserve sufficient time to understand this and prepare in case, and reserve a lot of time in case someone would like to be a partner in a call. And the partnerships for getting active in research and development is also important to build those up already before, like in the phase that a call is being published. And the preparation and organization and all the administrative activities also during projects, but also afterwards are quite high, and the payment conditions also need to be understood. If SMEs would like to enter and maybe are like newcomers, it's also possible to try to link to companies who take the role of a beneficiary, and as an affiliated entity, an SME could very much learn about the activities and the tasks that need to be performed by a strong partner who would be in the role of a beneficiary. What I also would like to recommend is to visit several web pages. So I included here the link of the Funding and Tenders portal. Also definitely worthwhile to learn about Europe's rail and follow what actually the market needs, because the railway operating community definitely also shaped what is going to be worked out in the next couple of years until 2031, and also the possibility to get familiar with the European Duct Delivery Program, where I mentioned it's actually an open platform. So if you have resources, expertise, capacity, then I would also recommend to join the European Duct Delivery Program. We can go to the next slide because I'm finished 2 minutes after. Please excuse me. Here you can see my contact dates, data, but also from various other stakeholders in case you would like to get in touch with those. Thanks a lot. And I'm also happy to take some questions, but we probably need to make it short.
Thank you very much, Constance. It was really interesting to see all about the DAC program, and also thank you for providing your insights for SMEs so they can perhaps be more familiar with this ERGU program. As you say, it's not so easy to understand all the framework but it can be very interesting. So you can, I don't know, yeah, you can see maybe that Lutz, thank you very much to provide the questions. So can you see them, Constance?
I can see them. Thank you very much. So the first question: at what stage is the digital automatic coupler now, and what should be the next steps for the future? So what we can see here is that we definitely do not have a market-ready product at the moment now, but we have built up the framework to work on this and to bring it to a high technology readiness level within the project, and also definitely the needed testing in the scope of the Europe's RAIL. The sector is currently in the phase where they are defining the next steps for the deployment. So the boards of the European DAC delivery program that I was mentioning before, they are currently working on an aligned time planning and also the necessary steps. Obviously, on the migration planning, so how we are going to deploy, because it's like affecting the whole freight sector. If we are going to do the step where we would like to really deploy the digital automatic coupler, a concrete and solid migration planning needs to be done. We need to have the technology ready, and obviously also the sector needs to agree. I mean, this is definitely a point that the program managers have taken a lot of effort on for the sector acceptance, and this is the main focus areas they must, and what we are actually also working on. The second question is, where do you see the added value for the DAC for the rail freight sector? Here, I was pointing it out before. I think when we are going for any innovation, we need to be quite certain about the challenges we are facing. And we are definitely facing the problems and challenges in the field of capacity, productivity, and also quality. And if I break it then down with the digital automatic coupler, but all the applications that would come along with the digital automatic coupler, then we would have a positive impact on those categories, including safety from a worker's perspective. And this is what we are currently following. And yeah.
That was the last one. I suppose that how do you propose SMEs to get involved? I suppose that you were developing it in your slide, so I think you had quite already answered to the question.
You're right, thank you.
Okay, so I think perhaps we have little, I mean, we have some few minutes delayed on this webinar, but just to obviously to go now to the conclusions, and perhaps I will just thanks again very much our speakers, and I think you bring very interesting and high value for this webinar. That I want to say also that everything we will distribute and allow all people that couldn't attend today, because also it was maybe difficult for them, or we are at the end of very heavy months for bank holidays and so on, so they can go to the platforms that you show now, Lutz. And maybe Lutz, I will say some words about the next steps and the event about it. Thank you very much.
And if you are wondering, it was me that I feeded the chat with different links. The first one was to the YouTube channel, where every STARS tutorials can be found afterwards. The second is the information that STARS project will conduct a fourth hack and match event on digital twin and artificial intelligence for railway processes, products and services. Both the call for challenges as the call for solutions are currently open. and you will find some more information on our B2B matchmaking platform, because Hack and Match is not only hackathon, it's also matchmaking, and there will you find the information. I see it is not quite on the current stage. I will check it in a few minutes and update it. And so you have also the chance to meet each other by installing a short profile about your company, maybe also to install some marketplace opportunities, and then you are able to meet with other participants of this platform. I will not forget to announce the next 2 STARS tutorials we already have scheduled. The first one is on advanced material usage in railway industry, and it's on the 2nd of June. It's next Tuesday already, from 13:30 to 15. All times are Central European Summertime. Because we have also participants from UK, for instance, and from Turkey, and therefore it is important to notice the registration is still open. The registration link is to be found in the chat, as well as for the new STARS tutorial on managing heterogeneity of IoT data sources, interfaces, and protocols. On Thursday, the 15th of June, from 2 to 3 p.m. and the registration is also already open. So that is my last slide, yeah. And maybe the last word is to Florence.
Yes, okay. So just thank you very much, Lutz, for this. And now it's the end of this webinar, and I must thank every participants. Once again, very warmly our speakers, but all the participants who have stayed at this lunchtime, and hope you're not too hungry. But thank you very much again, and you can find the information, as we say, on the STARS platforms, and hope you will participate to the next ones. Thank you very much to all. Bye-bye.
Bye-bye.
Thank you very much. All the best.